Alright nerds, so basically today we're going to our next video about controlling the rate of reaction, and we've got one more after this, and this one's about surface area. So basically when we look at surface area to volume, we're looking at a ratio, and a ratio is where we compare numerically one thing, so amount of something to another, and it looks a bit like a division here. So the surface area of a substance is the total area of the surface. I know it's pretty simple, but it's about to get more complicated, so chill out. We measure that in meters squared, or to be honest, in science we're going to stick with centimeters squared. Volume is the space taken up by an object, so we've got the amount of area that covers it and the amount of space taken up by it. Now we can measure that in meters cubed, but in science we tend to stick to centimeters cubed. So 1 centimeter cubed, by the way, is 1 milliliter. So 20 centimeters cubed is 20 milliliters. So the surface area to volume ratio is one that compares these two properties, and this has a lot of impact for life. Basically, it's what limits the size of cells and all sorts of stuff. So let's have a look at a couple of examples. We'll start with the 2 millimeter cube. We're going to say centimeters just for the sake of easiness. So in the surface area with this one here first, we'll go a centimeter cubed times 6 is centimeters squared. So that by that is 6 centimeters squared, whereas the volume is 1 times 1 times 1. So it's 1 times 1 times 1. Remember, volume is volume equals length times breadth times height. So that times that times that. And if it's all ones, then it's 1. It's still 1. So the surface area to volume is 6 to 1. Now, 2 millimeters cubed. The area is 2 squared. 2 centimeters squared. Just to make that easier, 2 centimeters squared. So if something's 2 centimeters squared times 6, that gives us an area of 24 centimeters squared. Now, crazily, the volume is 2 times 2 times 2. Now, so that's these two first. This gives us 4 times 2, that's our order of operations, which gives us 8. So it's 8 centimeters cubed, which gives us a 3 to 1 ratio. So 24 divided by 8 is 3 to 1. Alright, so you can see here that the ratio is getting smaller and smaller and smaller. Now, what does this mean for a chemical reaction? Well, here we've got two we can compare. One is a relatively solid chunk, and the next one here is a broken up chunk of probably a metal of some kind. So our observation is if the surface area to volume ratio increases, so the smaller the size pieces, the higher the surface area to volume ratio. So as the surface area to volume ratio increases, the rate of reaction increases. So what does this mean? Our conclusion is that basically there are more particles available to collide, so there's more open spaces, so the collisions happen at a faster rate. For example, all of these atoms which want to collide with this chunk of metal, they can get to the ones on the outside, but they can't get to these ones on the inside. So that actually leaves very few for it to react with. Whereas down here, you've got all of these, all of those down here. So you see there's just a lot more to collide with. Alright, so that's surface area to volume. I hope that makes sense. And we'll do that in the lab and all will be gold. Okay, see you later.